Hello everyone, we're looking now at the last part of the paper from November 2021, paper 2 for Edexcel. And I must say that as we get towards the end of the paper, the questions start to be more and more like A-level. So if you're in GCSE and you're thinking about taking A-level, then you want to know what it's like, then really the questions, the last few questions in the paper are a better indication of what A-level is like. So question 15, now I've put the mark scheme up here so that you can see it as well. And what we're looking for in this question is we're looking for, it's called extended trigonometry, and this one's going to be a use of the cosine rule. So what do we have? It says here is a triangle ABC. Find the length of BC. Now the first thing to note is that in this particular instance, we have got two sides and we have got an angle in between. And when you've got two sides and an angle in between, and you're trying to find out information about the other side, you're going to be using the cosine rule. So that's one of the patterns of when you use the cosine rule, when you have two sides and an angle in between. The other pattern for when we're looking to use the cosine rule is when we have all three sides and we're trying to find an angle. Okay, so those are the two scenarios in which we're going to be using the cosine rule. Now we can see clearly here we have two sides and an angle in between. So it fits this format and we're trying to find this side here opposite. So we just start by writing out the cosine rule, and the cosine rule is that a squared is equal to b squared add c squared minus 2bc cos a. Now the first thing to note is it does not matter which side you call b and which side you call c. The only thing that matters is the side that you call a must be the one that is opposite the angle, and it must be the side that you're trying to find. So here, subbing into the cosine rule, I've written that cb squared, which is our a, is equal to 8 squared add 11 squared. Again, it does not matter which way around you have those, minus 2 times 8 times 11 times the cosine of 72. So I've subbed my a is going to be what I'm trying to find, my b is 8, my c is 11, and the angle A is 72. So those pieces of information have been subbed into that formula there. We then just evaluate that and we find out that that gives us that the side is 11.4 centimeters to three significant figures. Okay, next one. Find the area of the triangle. Okay, we have two sides and an angle in between. And again, this is the pattern that you're looking for, two sides and an angle in between, when you're using the formula area equals half AB sine C in order to find the area of a triangle. So the area is a half AB sine C. Again, it doesn't matter which one we call A and which one we call B. So I'm just going to say a half times 8 times 11 times, this time notice it's sine, not cosine, of the 72 degrees, and that is how you work out the area. So that is 41.8. So that's question 15. So let's look at the next one, question 16. So question 16, use the iteration formula. xn add 1 is equal to the cube root of 10 minus 2xn to find the values of x1, x2, and x3. So it's our old friend, what I call spam equals, which is a reference to Monty Python. The spam, the word spam entered the vocabulary from a Monty Python sketch in which the only things that they sold in their cafe were sausage, egg, and spam. And the word spam is said so many times in the sketch that it came to be, that's how it entered computer science. Okay, now let's have a look. So the first thing we need to do is program the 2 into our calculator. So we put 2 in the calculator, put 2 and press equals. So 2 has now been programmed into my calculator. Don't press anything else, don't press cancel or anything, just now press the cube root button, okay? So I'm pressing the cube root button, and the formula is 10 minus 2 times xn. So I'm going to do 10 minus 2 times, and here's the key thing, I'm going to press that answer button there, ANS, okay? Now that is programmed into my calculator, and what's going to happen now is every time I press equals, I'm going to do one loop around the recursive iteration. So currently, XO is 2, I press equals, I've pressed it once, and I've now got x1. Okay, so I'm going to write that answer down. That is my x1, which would go here. I press equals one more time. That's one more loop. So that is now my x2. the 1.8533. Okay, I now press equals one more time, and that is x3. So I end up with 1.844626. And then you just give them all to the suitable degree of accuracy. Does it say? No, it doesn't say. So just write down to whatever degree of accuracy you want, and that will be fine. But that's how you do recursive iteration. You put the initial number into your calculator, and then you program it in using that answer button. Okay, and every time you press equals, you'll go from x0 to x1 to x2 to x3 and so on. Really nice really nice question there initially for those 3 marks. Now, it says the values of x1, x2, and x3 found in part A are in fact estimates to the solution of an equation which is of the form ax cubed add ax add b equals 0. Find the values of a and b. So in a nutshell, what they're saying here is that this formula here is a rearrangement of a formula that was in that form. So they want us to rearrange it back into this form again. Okay, so that's what we're about to do now. So let's rearrange it back into the required form. So firstly, to undo the cube, we're going to, the cube root rather, we're going to cube it. So that's step 1, we're going to cube both sides. So x cubed is equal to 10 minus 2x. The second step is we're going to add 2x to both sides. So x cubed add 2x is 10. And then finally, subtract 10 off both sides. So we now have x cubed plus 2x minus 10 equals 0. So our a is 2 and our b is minus 10. And that's what they want for the end of question 16. Okay, question 17, histogram question. And it's towards the end of the paper, so we can expect it to maybe be a little bit tricky. Let's have a look and see what they're saying in this question. There's the mark scheme for you. Okay, it says some people took part in the first round of a competition. The histogram gives the information about the scores of these people in the first round. 20% of the people got a score high enough for them to qualify for the second round. Work out an estimate for the score needed in order to qualify for the second round. You must show all of your working, and this is worth 4 marks. So step 1 is we need to know how many people there were. And you may or may not remember that the area underneath the histogram is what gives us the frequency. So we need to find the area underneath each one of these graphs. So first of all, let's have a look. This bar is 0.8 high and it is 5 wide. So it has an area of 5 times 0.8. The second bar is 10 wide and it has a height of 1.6. So that is 10 times 1.6, that's an area of 16. The third bar has a width again of 10 and a height of 2.2. So its frequency is 10 times 2.2 equals 22. And then finally, what have we got here? We have from 25 to 40 is going to be 15. And we have a height of 1.2. So we have 15 times 1.2 is 18. We add all of that together, and that tells us that in total, there were 60 people who took part in the first round of the competition. And the idea that we've used there, let me just write that down, is that frequency is equal to the frequency density times by the class width. That's the formula that I've used there. Frequency is frequency density times the class width. So if we look at the first one, the class width is 5 and the frequency density was 0.8. So 5 times 0.8 gave us the frequency. Perfect. So we now know that there were 60 people. So now we need to know, it says that there were only 20% of these people qualified through to the next round. So what is 20% of 60? Well, 20% of 60 is 12. Okay, so we need to have an area that corresponds to a frequency of 12 people. So we just need a frequency of 12 here. Now let's think about how we're going to do that then. Okay, so we know that we need an area of 12. We know that we have a frequency density of 1.2. Okay, so 12 divided by 1.2 will tell us how wide the bar should be in order to give us that frequency of 12. Okay, so what we're basically saying here is we're basically saying that our frequency divided by our frequency density is giving us our class width. Okay, so that's what we're doing here. So 12 divided by 1.2 is 10. So the width of this bar needs to be 10. So from the 40 rather, we're going to go back to 30 and draw a line there. Now what this means is that the score that you need to achieve in order to qualify to get through to the next round is you need to achieve a score of 30, okay, or more. So 30 is the answer to that question. Perfect. We'll just do one more in this video. And this is nice graph transformations. Again, all of these last few questions are at the beginning of A level for those of you who are interested in knowing. So here it says is a graph of y equals sine x. For x is less than 360 but greater than 0. Using this graph, find the estimates for all solutions of sine x equals 0.6. Notice it goes from 0 to 720. Okay, so first thing we need to do here is draw a line on at 0.6. And you can see our scale is here is 0 and that is 1. So I've drawn a line on at 0.6 all the way across. And it only gives us two solutions, that one there and that one there. So we just read down there, and that corresponds to 37. I think that's roughly about 37. And then we read this one off here, and that corresponds to 143. Now, those are the only two solutions that are in the interval from 0 to 360. However, if the graph was to continue all the way up to 720, so there's our 360, here is 720, you can see that we would have another two solutions. And notice that these extra two solutions are one full wavelength on from the previous solutions. So in this particular instance, what we would do, find the other two solutions going from 0 to 720, is we're going to add 360 to each of the solutions we've got. So that one, add 360, that gets us to 397, which would be over here. And then we've got this one, and we add 360, which gets us to the fourth solution over here, or there on that diagram. 143, add 360 is 503. And that's our four solutions that are in the range 0 to 720. And you can see here they are 1, 2, 3, 4. And that's how we would find them. Okay, next one. The graph y equals sine x is reflected in the x-axis. Write down an equation of the reflected graph. Now, when I was learning this, I've written here, when you reflect something in the x-axis, it's f of minus x. And when you reflect something in the y-axis, it's f of minus x. And when you reflect something in the x-axis, it's minus f of x. Now, when I was learning this, the way that helped me to remember this is the f of x value is the y value. Okay, so if you've got a graph and you have a y value and you put a minus in front of the y value, it's going to end up down there. And if you do that to every single point on that graph, put a minus in front of the y value, you're reflecting it in the x-axis. Okay, so that's what helped me when I was first learning these graph transformations. So we have got a reflection in the x-axis, so that means we need to put a minus in front of the function. And if the function is y equals sine x, we need a minus in front of our y value. Okay, so that's the answer. It would be minus sine x. Quite advanced stuff for GCSE, but as I say, you'll be practicing this an awful lot in the beginnings of year 12, those of you that take A level. Next one. It says here is the graph of y equals f of x. On the grid, draw the graph of y is equal to f of x minus 2. Now, when you've got this in brackets like this, these are translations. Okay, I'll write that down. That is a translation. And when it's inside the bracket, it's a translation by vector minus a0. Now, what does that mean? That means that the graph is going to go either to the left or the right, but when it's inside the bracket, it goes the opposite direction to what you imagine. So here we are on our original graph, and although we've got minus 2, which you would think means you need to go that way, in fact, it means we need to go to the right by 2, so we need to add 2. So the whole graph moves from here across to here, like so. And that is our new graph. The whole thing has been translated by 2 units in the positive x direction, because this would be a translation by vector of minus, minus 2, 0, like that. So in other words, it's going to go 2, 0 or 2 to the right. Perfect. Right, I think we'll end that for this video. I hope you found that helpful, and I will see you in the next video, hopefully for the last few questions on this paper.